Okay, for people who are joining this live stream, we are looking at functions that are currently experimental in Wolfram Language, and we are discussing what it will take to make them not experimental, and whether that will happen for the upcoming new version. All right, let's start with synthetic geometry. So, okay, so we've got some things that are purely standard geometric operations like angle bisector and so on. And then we've got a class of things that are much more our specific theorem proving in geometry. Is that correct?
Correct. The theorem proving stuff actually hasn't even been released yet in 12.0. So
no, I mean the okay. What's happening with that stuff? Is that coming in 12.1 or what?
I think we're going to push back to 12.2, I think.
Okay. So my main issue with things like angle bisector is the concept of returning these symbolic primitives. I mean, maybe it's like, what else could we do? Oh.
I mean, they have definitely more semantic meaning than a set of vectors or lists.
Right. So yeah, basically the infinite line idea was that's the most useful thing for using it inside of geometric scene. Outside of geometric scene, maybe there's a
so I like
choice.
This behavior. I like it if you feed it, feed it undigested stuff, it'll come out like that, and feed it digested stuff, it'll come out like that, so to speak. That seems like a really good pattern.
Not everybody might agree. But...
Yeah, I think that I found out over the past few weeks that's a lot more controversial than I thought.
And which part of it?
The output part. I think accepting the different types of inputs isn't so controversial, but having outputs differ based on the head of the inputs,
we do that in many places.
Yeah, I mean, I don't think that in and of itself is the controversial point. I think the controversial point is I don't think we have a consistent set of rules for the different functions and the different possible inputs.
Fair enough. Well, that's what we should think about. I mean, so angle bisector, similarly, I personally don't like the fact that in this case, it's returning infinite line. I have no problem.
Right, but what else would it return?
Well, let's think about that for a second. Okay, so, I mean, if that was, what would that be? I see that. What the heck is that? I mean, that's not even a line. Well, it sort of is a line. I mean, if that was a line of those things, then I am confused here.
Right. So right, it's giving the 3-point syntax is taking those as the 3 points of an angle, right? So P1, right. Q, P2, and then it's giving you the infinite line. And of course,
it has. If those were a point, if those had head point, I would have zero problem with this result. Even if that was a line from that to that to that, I would have zero problem with this result. My problem with this result, I mean,
it is inconsistent with midpoint behavior.
What's that?
If you see it this way, it is inconsistent with the midpoint behavior, where the type of the output subtly depends on the geometric primitives in the input.
No,
I think that's
consistent with midpoint. Look at what midpoint is doing. Midpoint is if there's raw coordinates, it returns a raw coordinate.
That's what I'm saying.
Yeah. Okay. So now,
right, so wait a minute. But the point
there's no raw coordinate form of a line.
Exactly.
This is a special thing that only applies to midpoint because we've got two.
Well, let's talk about that for a second, okay? Let's talk about that for a second.
I mean, one could, of course, agree on one.
Right. I mean, let's talk about that. To me, what angle bisector does with geometric primitives is uncontroversially correct. If I put in, and I would advise this as and I really hate using these scripty things for these, but anyway, that's a different issue. I mean, if I were to put point into each of those, Oops, that's very wrong.
I totally forget whether this is going to work or not.
Well, it better work. It
Okay,
worked
good.
fine. Now the next
Good.
question is whether this works. It does. Great. Excellent.
But the real question is if you replace now point by line.
Yeah,
That should work, in my opinion.
it shouldn't, right? It should be two separate lines. This is like a polyline.
That is exactly the question. Like, what do we mean by line here? Do we mean line in the sense of graphics primitives or line in the sense of geometric scenes?
Right. 'Cause
Well,
one
no,
other,
wait a minute, but polyline, we
I
support polyline in both cases, don't we?
well, so for inside of geometric scene, there's an additional assumption if you do line of ABC that it's a straight line. So, this.
Wow.
Right. Well, it's really kind of necessary because a lot of these geometric scenes.
I understand that. I understand that.
It's the classic meaning.
Yeah. So, I feel like having angle bisector work on this sort of.
Well, that rubs one's nose in that issue.
Yeah.
All right. So hold on a second. Before we gloss over that, a polyline is not a polyline in geometric scene, is what you're saying.
Correct.
Or it's a polyline where all the segments line
With
in a
what?
straight
Are
line.
curvilinear.
Yeah.
Not
gonna get us
every
in trouble
polyline
somewhere.
is a line in geometric
Right.
scene.
That's right. That's the basic point. But I predict that's going to lead us into trouble somewhere, and I think we need to think more carefully about that. About
About
the
what?
possibility that we have somehow that we, for example, I mean, have we considered the possibility of a straight line concept?
We had very early on in the synthetic geometry project, we had something called line through, which is basically how line works now inside geometric scene, where it's basically what you're proposing here with straight line. But we abandoned it and just added the assumption to line.
The issue with straight line is it would be perfect for geometric scene and also perfect for symbolic inputs. What would it represent if it has a set of points that aren't on a straight line?
Well, it's similar to circle through because Charles supports circle through outside of geometric scene now. So whatever he does for that, I think would happen for straight line.
Well,
But like at which point would it give error messages? When used, when just written down?
I don't know.
Well, what does it
circle
do
through
for circle through? Is Charles here? I mean,
Well,
if I
it's
just put
For
random
circle
point,
through, I believe it does an error on symbolic.
no, I understand that.
Right,
if I
but
just
on
make
invalid
random-
ones, I think it will give you an error at evaluation time.
Yep.
Not the right way around.
Yeah, perfect.
That is not a very good error message. There, no circle can be. Oh, no.
No, it's wrong. You won't.
But that's, by the way, that's a bad message, even regardless. Okay, so for 3 points, we're good. It can go through them, right? Let's pick 5 points. Okay, that is a terrible error message. Come on, guys. We can do better. No circle exists going through. A circle through blah, blah, blah does not exist. Come on, let's make it literate, please. Fair?
We'll pass that on to Charles.
I think I imagine he phrased it that way, so that would also apply for if you did like a.
I don't care.
Okay.
I don't care.
But anyway, Stephen, there's a difference. Circle through, for me, the name suggests it makes a circle that goes through. So it does non-trivial evaluation. Where straight line has, for me, much more a similarity with line, which just is a primitive that is inert and sits there.
I agree.
So that's why there the error detection mode is much more complicated.
Right.
I don't disagree.
Which is why if we added this thing, right, it should presumably be line through, and which would for concrete values would either evaluate to align or error out.
Right.
Charles is here.
Okay, listen. I got a way to solve this. What if, so what circle through returns a circle, as you would expect.
If it can.
I understand that. What if we called it angle bisector line? And it returns a line.
A line or infinite line?
Infinite line, whatever. By the way, I assume infinite line renders in graphics okay. Yes, it does. I can see that down below. Angle bisector line tells me I'm going to get a line out. See what I'm saying?
Yeah.
And then, you know, and then, well, big surprise, I get a line. I mean, that would be because this, I don't even know what I would get out of this. That's my suggestion.
Right.
What's that?
When we were designing this, we all realized we didn't exactly know what an angle bisector was physically. So yeah,
I didn't even know what the angle is.
Yeah, this is a long discussion. So
Yes, start there.
That is a completely different question.
Okay.
So
I like this suggestion.
Okay, so for kind of related issues, if we go down to like triangle construct.
Hold on. But perpendicular bisector, so that would have the same story.
Right. Currently, it's just an infinite line, so we can do perpendicular bisector line.
I like this. This makes it.
I'm concerned with putting line in there because it's not our line primitive. It's an infinite line.
Right.
That's okay. It's already gives the idea that it's a line.
Right.
Not.
I would argue that so does being called angle bisector and perpendicular bisector.
Well, not to me it doesn't.
I mean,
Yeah, not to me either.
I would agree with that for perpendicular bisector. I'm not sure I would agree with that for angle bisector.
Right. But I think perpendicular bisector and angle bisector have to be parallel.
I mean, we thought about higher dimensions, and these things could be hyperplanes and all kinds of crazy things.
That is true.
We extend that in the future.
Great. Then they'll be called, angle bisector.
It's going to be blowing up the symbol.
I don't think that's right, because I think it's going to be a more. What is an angle in three? It's some dihedral angle somewhere. I mean, what is it? It's going to be complicated to say what you mean by that. Right. You see what I'm saying?
You're right. And also, until we have something that works in 3D, this will emphasize that this will not work in 3D.
Well, I wouldn't give that argument. My main argument is, if I saw angle bisector line, I know roughly what it's going to give. Line, infinite line, I don't know the difference. But angle bisector, you said, what is that going to give? I don't know. Maybe it gives the angle divided by 2. I don't know. Roger, you seem to agree with me.
I do.
Okay.
Okay. So for triangle construct, we have some string arguments that I think involve angle bisectors and perpendicular bisectors and related things. So you might want to have a look at those.
Okay, let's take a look at that. Hold on.
I just want
to perpendicular bisector line. Yeah, I like this. And the midpoint doesn't have a capital P. Now, I admit that that's a slightly, you get what I'm saying.
Right.
But it cannot be different.
Right.
No, it's the right thing. It's the right thing. This is midpoint doing what it's doing right now is the right thing.
Also, one other thing on midpoint is if your inputs, one is a naked list of coordinates and the other has head point, I forget whether it returns a naked list or with head point, but it does return something, which I would like to confirm is okay.
It's okay.
Try it the other way around.
Oh, wow. No, I'm going to do something more exotic.
Right, it only works on 2.
What do you get if you just do a
I
vector
see,
for the
I see,
first
I
one
see,
and a
I
point
see.
for the second one?
So I think, it picks
All right.
whatever's
That
the first
seems
one.
quite sensible.
Some logic to it.
Right.
Okay, so listen, another thing that I would like to suggest, an operation that I want with remarkable frequency is I want to go a certain distance between 2 points, a certain fraction of the way between 2 points.
So like a parametric line.
Yeah, I want to be able
Yeah.
to give a second argument, let's say, to midpoint, although that's a kind of a weird idea.
So you want the point or the segment you walked along?
I think you wanted the point, right?
I want the point.
Okay.
Right. I think you actually discussed this a while ago, and
I mean, I need that operation so many times. I mean, I'm just kind of wondering if there should be a parameter, alpha or something that's a second argument to midpoint with default value of half.
Do you need this for just a line or for a general curve?
I think I've needed it just for points a zillion times. I mean, it's obviously, it's obviously an easy computation, but it's kind of a nuisance.
Right.
You got to go.
Right.
Yeah, I think trying to expand this to anything beyond 2 points is just like
Right. I want to
any rectifiable curve or whatever. So yeah, within 2 points. Yeah, we discussed this, and I think just the main issue was what was the name, so we just stuck with midpoint without it. But it would it would certainly be easy to implement.
I would like to see it.
Okay, but I think
I would be okay with keeping it midpoint with an optional second argument, which we call like the fraction or something.
Yeah, that's what I would suggest. That's what I'm suggesting.
okay, I'll do it.
And we allow also numbers other than from the interval 0, 1 to go outside.
Sure.
Right.
Absolutely.
Okay. Midpoint with optional.
Okay. A few comments from our live stream here from Bob saying he likes the name line through and also suggesting angle bisecting line. I don't think it sounds as good as angle bisector line.
That's similar to what we have in triangle construct.
Yeah, you're gonna.
And when you pull up could you pull up the
Yeah.
source ref page?
For which?
Triangle construct.
As opposed to the built page.
Yeah.
Okay.
This is
That's a
going to
good
be
suggestion
opening up.
from Sander on our live stream suggesting a scaled. Well, actually, this is scaled in a sense. This is scaled. The midpoint thing is. Oh, I see. He says he was about to make a line part function for the function repository, which with a scaled option. I see, which is the same type of idea. This would be, the parameter in midpoint would be a scaled thing from 0 to 1.
Right.
But
Now,
then you
by the
couldn't
way-
unscale. I see Sander's point. It's very clever. Like, because you might go 1 in this direction. But if it's second one by default scaled, we cannot unscale.
I don't follow that.
Yeah. He's saying on the line, go distance 1 on the line from the initial point.
Oh,
And
I
the
see.
default would be automatic, which is exactly the distance from A to B.
I see.
So divided by 2.
Right.
Well, I think
Absolute distance versus a ratio.
personally, I think that Sanders go that distance on the line thing, line part. I'm not sure line part is my absolutely favorite name for it, but I think that will be a fine function repository thing. I think for midpoint, it's got to be a parametric fraction. Here, by the way, does midpoint work for 3-dimensional things? It certainly should.
I forget. Charles had some opinions on whether these things should work on 3D. I think midpoint does, but the other ones don't. Yeah, good.
Okay.
Right, because midpoint is very unambiguous in NERN.
Right.
Mm-hmm.
So what happens with line of a list of points if you have more than 2 points? I just don't know the answer to this.
With midpoint.
Well,
Does it only work if they're collinear? If it's a jagged line?
I implemented this long enough ago. I do not remember what happens.
Well, maybe it just ignores the ones in the middle. I don't know. Or does it give an error?
I can look up the code. I think
It's called region centroid on the line.
Oh, right, that's right. Because if the thing is, if the line doubles back over itself, then you can't just go, you can't add up the distances and go. So basically, the region stuff, if a line doubles back over itself, it doesn't consider it parametrically where you're moving back. It just considers just the geometric object. So I have to call region centroid in case there's a whole bunch of double backing or whatever.
But
Right.
does it only work on the straight line case? Because region centroid will generally put it off the line if it's turning.
Right, but what is the midpoint of something that doubles back and then
Exactly.
isn't a straight line? Yeah, I
wasn't really comfortable with putting this in.
Right.
Yeah, it doesn't make a lot of sense to me.
I don't remember what the I can look up.
I don't even understand why we support this at all.
That was my argument, was not support
I don't think we well,
so
I think no, midpoint of a line with 2 points is fine, but right. Midpoint of a line with n points just doesn't seem like, I don't think Euclid would have talked about that. It doesn't seem to me to be very meaningful.
Okay, I think maybe the reason we have that is because, again, inside of geometric scene, line of 5 points is a straight line, so this is meaningful and something someone might want to actually do.
I would argue it's pretty, yes, but in the case of a concrete line, there's all kinds of machine epsilon-y type stuff and so on.
Right, but if we replace line with line through for inside of geometric scene, then it's problem solved.
Right. Actually, I've got a few comments from the live stream. Bob is mentioning the name point lerp, but I do not know what that is. If there is a thing called a lerp, I've never heard of it.
How is that spelled?
LERP.
Live action role playing.
Is that all we know? Oh, linear interpolation, lerp. Oh, wow. Basic operation of, in graphics jargon, it's called a lerp. I did not know that. Unless that's somebody faking out Wikipedia in some way. Wow. What do you know? Well, yet another thing learned.
That is an impressive fake out.
If it is, which it probably isn't, but well, apparently that's what it's called. Okay, well, that's certainly a keyword that we should have. Thank you.
Yeah.
Yeah, I mean, that's exactly the operation we're talking about here.
So did you want to look at that triangle construct?
I do want to look at the triangle construct. There was also a question on the live stream about whether interpolation works on points. Okay, let's look at triangle construct.
Right. So
okay.
The source ref page, I mean.
Oh, the source ref page.
Right. We've added some stuff.
Oh my gosh, this is a super function.
Yep.
Look at all these creatures. Okay.
So draw your attention to angle bisector and angle bisecting Sevian. One being just a line.
What does altitude? Okay, so what do these things actually return? So, I really wish you wouldn't use these blasted, incomprehensible, obscure, scripty symbols for things. Why are you doing that?
I was following the example of other geometry pages.
Great.
They use script R for region and things like that.
Well, that's different. It's a capital R, and you can actually see it. Here, this just looks like a little glitchoid on the page to me. What is that thing anyway?
I can change that to just say alt equals.
I think it's a script L, right?
That's presumably a script lowercase l.
Right.
Maybe if you needed a script capital L, it would be better.
But what is it? Why would you call anything a script lowercase l?
Because it's a line.
Because it's a line.
Oh, boy. I would just call it line or something. Really, I just think that raises a sort of cognitive level for people of what is that? Is that math? Is that something else? Anyway,
I'll change it.
Yeah, I think the main problem is the non-script L just looks like a 1. So
and why do you have to name? Oh, I see, because you're going to use the triangle again
Right.
here.
Although you could always just use %, right? If right, and in such a small
Percent.
sample,
but
you-
Yeah, you got to name the triangle, unfortunately, here. Okay, so this thing, in this case, you're telling me that you are returning for the altitude here. You are returning something that is graphics friendly, and you are
Right. So triangle construct always returns something graphics friendly. So if there's if the thing being constructed is a point, it has a head point.
Okay, I had forgotten that the right name here is triangle construct, not triangle construct.
Although if your optional argument is triangle, then it will construct the triangle.
What do you mean construct the triangle? Which optional argument? This one?
This
here?
one, right? So that's just because if you
You didn't have a triangle, and now you have a head triangle object.
right, and if you omit that's the default if you omit that argument.
Okay, yeah. What else could it possibly do? Okay, so you say, by the way, there's no autocomplete here. There was no autocomplete at all here. Somebody needs to fix that.
Okay.
that's missing source notebook tagging. If you don't know how to do that, I can teach you, Ian.
Okay.
Yeah.
Okay, that's a beautiful infinite line. Is there a problem with that?
That should be fine. I think the reason we're discussing whether we should have this also change to angle bisector line.
I think the answer.
So I want to say there's another thing you could put there, which is angle bisecting Cevian.
Right. Cevians were had some awkward names just because there are lots of.
I never knew about Cevians until we were doing this project.
Right.
Right.
So I'm not super thrilled with this.
What does it even mean?
So a
Cevian
Cevian is in a triangle is a line that has one endpoint as a vertex of the triangle and its other endpoint in the opposite side, and it can be defined by a point in the triangle it goes through. It could be defined by.
So what's the default Cevian?
The second
angle.
argument, and you use the centroid for
Right.
the second point you're going
So
through.
it's,
Oh, okay, fine. Yeah, I remember that. Okay. So what is this? So this is it uses randomly the second one of these and the centroid. You're saying by
It's
default.
not random because they're like angle bisector, for example, will default to the second, and for anything else, there's no preferred default, so might as well use the second for everything.
right.
Okay. So the thing that concerns me, I mean, altitude doesn't say altitude line, even though it is a line.
Right.
An angle bisector, I would say don't bother to say line here.
Okay.
I think that
I mean, we can make it work in addition. One
Yeah,
more
we
string
can make it
argument
work.
doesn't hurt.
Well, also,
but don't
the
put
fact-
in the autocomplete.
the fact that triangle construct always returns a graphics friendly thing should clue people in.
Yes, I agree.
Right.
I don't see a problem with that.
Okay, so also just to point out, so triangle center, for all of the string arguments for triangle construct that return a point, you can use those as arguments for triangle center, but triangle center always returns the naked coordinates. This is just something where when we were doing the design, I think the centers were an important enough part that you thought they needed their own head.
Yes, and then
but-
they should just return coordinates.
Okay,
Yes,
good.
I
That's
agree.
what happens. Okay,
Yeah,
just
there's
making sure that's
no
simple.
point. You have to say point of triangle center if you want the triangle center point, so to speak.
Okay, good.
And
No,
similarly, triangle measurement is not returning. Presumably triangle measurement is mostly returning numbers.
only returning
numbers.
numbers.
I think triangle center. Yeah.
Can we circle back to triangle construct for just a
Yes.
moment? So in the details and options section towards the bottom, I had a different proposal on how to specify what form of angle bisector to have. Yeah, right there, the line type.
Oh my God, what a can of worms.
Yeah, we talked about this. I feel like this is complicated.
By the way, why is it an infinite line? I don't understand why it isn't a half line in the case of the generic angle bisector line.
Well, because half line makes the value judgment that it should either go through the the smaller, it should be what direction should the half line point?
But I don't. That's why you have an interior and exterior.
Right.
Well, also in a lot of constructions, I mean, you do the angle bisector and then you talk about the supplementary angles. I mean, it is a useful thing, but
what's a useful thing? The infinite line or the half line?
The infinite line.
Okay.
I don't think we have a good story here on choosing whether you want the infinite line or the half line or just the line segment, and we're not doing it the same way in triangle construct and with the standalone angle bisector function, I think is
right, because in the sense, angle bisecting Cevian is what should be called. Well, I guess we have an extra. We have more data here because it's a triangle and not just an angle, right? But that's the thing that sort of returns a line.
Yeah.
Whereas people are going to probably have heard line and not have heard of Cevian.
Okay, so hold on a second. So I'm now concerned about the angle bisector line thing and whether it returns half lines or infinite lines.
I think you want
infinite line.
You want infinite line, half line, and a line segment.
What's the line segment for?
If you're in a triangle, you'll talk about the angle bisector is specifically the line segment from the vertex to the opposite.
So why doesn't angle bisector line take a triangle as its first argument?
Exactly. We're covering this, and if you want to do that right now, it has to be in triangle construct. So
I understand, but we could also make angle bisector take triangle as a first argument.
Okay, what are the second arguments? What's type?
Interior, exterior. I don't even understand what that means. That only determines the direction of the infinite line, right? If it's an infinite line.
There'll be two different infinite lines that are at right angles to each other.
Right. It's
the exterior angle is the supplementary angle to the angle.
I think if you go down to the
exterior angle bisects that angle.
Right.
I'm confused here.
It's one of those things that exists in geometry, but the name is not exactly not exactly tell you what it is.
Wait. What I understood was that there's an angle formed by two lines, right? And there's the bisector which goes in the middle of those two lines. And
by the way, that reference entry would do well with an illustration, and we wouldn't even have this discussion because you would get right away what the concept was.
Yes, good point. This needs an illustration. As do I'm just amused by somebody on our live stream saying that triangle center seems very ambiguous because there are lots of triangle centers. That's commend your attention to the actual list of triangle centers here, and the fact that you are required to give a second argument to triangle center, which says which one you're talking about.
Well, I don't think
actually centroid is.
Yeah, centroid's the default.
Oh, there is a default. Why isn't the default shown up here?
I don't think that's super useful.
Is there a separate thing where you can ask for centroid?
Region centroid.
Yeah.
I think you should show that default there.
Okay.
I think it is useful.
Yeah, and generally speaking, we've moved in the direction of if there's a default value for the argument, we show the one argument form in the main usage because that.
Okay. So will we do the same on triangle construct? The one argument form is equivalent to just
no, because
triangle?
it's a completely silly one argument form that nobody would ever use.
Okay.
Whereas triangle center is a one argument form that people might actually care about.
Okay.
In that case, I would put it as a subsidiary thing. Don't forget to tag it for syntax coloring and so on. Right? You know about how to do that. Yeah. Okay, so I want to come back to our friend angle bisector. Okay? And I want to understand in what sense I am now totally confused. Okay, so here's a pair of, I mean, I don't know why you show this example, which has many additional confusions, because it's a, I mean, why don't you show an example which doesn't have a right angle here? I think you need to do that. Okay.
Okay.
Don't show a right angle, but anyway, so there's an infinite line that is going, now what I would understand is the exterior angle would be this angle here. Is that wrong?
That so for
non-standard.
For like,
yeah,
right.
we talked about this earlier. Your notion is what we call full exterior angle.
Right. If you look at the
just tell me what
you're
saying, that the exterior angle is some bizarre thing where it is.
It's the supplementary angle.
Right.
Supplementary with respect to which initial line?
In planar angle, we try to explain it.
Doesn't matter, right? The bisecting, the infinite line will be the same in either one.
Yeah.
Which one? Planar angle?
Yeah, planar angle has an explanation because it's just a definition in geometry that we have to deal with.
Those pictures need to exist in the other one as well.
Right.
Yes. Pictures like that. Okay.
Right. So that is another argument.
Scroll down on that page.
Yeah.
And there's another interior, exterior, and full exterior. You scroll past it.
Yeah.
No, I'm looking at the examples here. Planar angle is the angle. Hold on a second. This is the angle. This is some counterclockwise angle formed by those things at that point, right?
No,
I think the default is a smaller angle. So the angle less than pi.
Oh, so it's not a counterclockwise angle.
Right. You can add
Unless
in
you ask for that.
Yeah, you can add in the string argument.
Okay. Well, what does it do by default? It just picks the smallest one?
The default is interior.
Yes.
Which is defined as the smallest, the one formed by that triangle.
Right.
Yeah.
In the interior of that triangle.
And
Okay. So bizarrely exterior, and I probably should have been paying more attention in my geometry class 50 years ago or something to know that, is that angle there. Okay.
Yeah. And then
so that means that the bisector could be there or could be the perpendicular line here.
That's an argument in favor of keeping it infinite line because, for instance, for the the exterior angle, there are you could pick that one, you could pick the other one. The infinite line works for both of them.
Yeah.
Oh, well, it's just a matter of be clear about what angle are you specifying. In planar angle, we try to make it clear, right? Even with the syntax rule where you say P goes to Q, Q1, Q2, you have to really specify which angle. Is it the interior one or the exterior one?
Even though those two syntaxes are effectively equivalent.
Yeah.
Right, but you have to pick. Right?
Shouldn't you support this syntax in angle bisector line? Right, because that would be from that point to those other points, it's the same story as with planar angle.
That is fair. Can you check? I forget whether we do or not.
We didn't.
Okay.
In the
At least it's not documented whether or not it works.
It's definitely not documented. I coded that up a long time ago, so I don't remember whether I actually supported that.
All right, so let's come back again to this question. So an angle here, notice, by the way, the angle has no units, which is the right thing because most of our angles don't have units.
Yeah.
No, that's a wrong. The statement is correct, but the argument is wrong.
Okay.
The angle is the object. The angle measure has units.
Oh boy,
But
and this is a famous issue, right, Michael?
Yes.
Whether can you give the one-sentence summary or two-sentence summary of the whole question about whether radians should be a base unit? Is that what that's about?
No, that's not about. But here we speak about the object. Say either an angle or a line, and they have properties like lengths or angles, or like a polygon has a measure. It's the area.
Mm-hmm.
That's why we have to differentiate between the angle and the measure of the angle.
What? What is the angle then?
The sink,
Right.
the
I see.
cone, the set of points.
Well, but that's not what this is. Planar angle is returning a number.
Right.
Yes, but I know,
And-
but
And it's documented as the length of the arc.
Conceptually, there's
of
a
the
difference
unit
between
circle.
an angle
Okay.
itself and an angle measure, but in the
Yes.
system, we only deal with angle measures.
Right.
Okay, fine. All right, back to angle bisector. So clearly it has to be consistent with planar angle.
Right. I'll make those changes for the inputs.
But I wouldn't document it first as it's done in planar angle because I think it's obscure. For angle bisector, I think you're more thinking about it as a line, because not least because planar angle deals with, you know, higher dimensional things and all kinds of wild stuff. But angle bisector line, I'm still okay. First of all, I'm even more convinced that it should say angle bisector line after seeing, but I'm now totally confused about, it could be a half line starting at P in the case of in the notation of planar angle, but it is in fact an infinite line for reasons that I don't fully understand.
Okay, so by always returning an infinite line, it sidesteps the question of whether we're bisecting the interior angle or
Well, the full
exterior angle.
Right. But we still are confused by the interior angle, which is again arbitrary because there are two interior angles depending on which line we chose to make be the base. Correct?
They would. Are you talking about counterclockwise versus clockwise?
I guess I am.
You're
Yes.
right.
Because
So
that
it
would
sides-
give the same.
Right.
Bisector
It sidesteps.
cases.
Yeah. I mean,
So-
Even if it was a half line, it would still. Right.
We still have that issue, right? Of whether it's the clockwise or the counterclockwise exterior angle.
It's really just the big
it's
angle.
not
or the
clockwise
small
versus
angle.
counterclockwise, right?
Hmm.
There are three angles we need to worry about. The interior angle doesn't matter which base because the bisector is the same.
Yep.
There's the exterior, where I suppose there, if we decided to start drawing it as a ray rather than as a line, then it might matter which one we chose to extend. And then there's the sort of full exterior angle, where it doesn't matter. You know,
It would have to point in the opposite direction as the interior angle.
right.
So
Right. So we could, I mean, right, this convention is taking, right, Q1 to P to Q2, and exterior is defined in a particular way, which I forget which side it, right, we can look at the drawing for exterior and see which way, but I think it's extending from Q2 to P and then finding that angle.
well, but exterior, it's the measure, so it doesn't matter which one we choose.
Oh, you went to a different page. I
If
see.
you do the infinite line, it doesn't matter which one.
Right, I
So
know, but I'm saying
yeah.
Itai was talking about like on a planar angle, I thought, but since planar angle returns the measure, it doesn't matter which orientation we choose. It's just what picture we use for the documentation.
Why doesn't planar angle have why isn't it a signed angle?
Well, it's only signed if you choose clockwise or counterclockwise.
Is it actually returned a sign thing?
Don't.
Well,
I
it's a matter of defining what angle you are picking, right? So you use the sign because you say you are is counterclockwise on the way you measure things. Right?
But I see, but
So
you're not
this-
using sign, you're using it mod 2 pi.
Right.
So it doesn't in fact have a sign, it's just the mod 2 pi result. Always in the interval 0 to 2 pi, is that correct?
Right. But here the key thing is to define what is that cone, the actual angle, and planar angle gives you then the length of the arc. So how do we define actually the cone when you say P goes to Q1, Q2, right? That's the crucial
Yes.
thing.
But
And
I
now
mean, it doesn't seem self-evident, Charles, that and it probably should say it in this documentation, that it always returns something in the range 0 to 2 pi, as opposed to minus pi to pi, for example.
I think it says that.
I think it's written somewhere. We made
Okay,
sure
fine,
to write
fine,
it somewhere.
I don't see it here. Oh, no. Well, implicitly it does. Okay. I was seeing in your other documentation somewhere something where you had a second element in one of these. I guess it was in triangle center, maybe?
Triangle construct further down.
In the futurized note.
Oh, yeah, there, where you're saying the infinite line or the half line.
I would like something like that for angle bisector, where you can specify that you want the infinite line that kind of squashes some of these cases into the same case, or you might just want the ray, or you might just want the line segment. So we would probably need some kind of spec for what angle are we bisecting, and a spec for what type of output.
Yeah, but it's going to be the same type of thing as you get here, where it's...
Well, except that, I mean...
But I mean, you want all three of these things. Angle bisector, interior, infinite line. All three of those are relevant. Angle bisector, exterior, infinite line.
Exactly.
Right? You could have that in the triangle construct case is basically the same thing as the angle bisector.
Yes, that would be my preferences. For triangle construct would be a list with interior and infinite line, and angle bisector would be a function that could take up to 3 arguments.
Did we have as the string argument for triangle construct? Do we have exterior angle bisector? Yeah, we do.
That's another thing. Like,
so would we
exterior angles are handled with a string argument in angle bisector, just interior versus exterior, whereas here we need 2 legitimately different string arguments for exterior angle whatevers and interior angle whatevers, and then also different ones for whether it's a Sebian or whatever, and I don't think that's ideal.
Okay, hold on. So here we've got an explicit exterior angle bisector. Here you're proposing a string argument to angle bisector line that says which angle bisector we're talking about.
And what kind, do you want it to be an infinite line? Do you want it to be the ray? Do you want it to just extend to the opposite side of the triangle?
Oh gosh, a line segment like that. Yeah.
Because that's also important.
I feel like these functions are kind of over-engineered enough. I feel like...
Well, but it's a big pain to
for consistency.
Look, I think, okay. I think what we should do, whatever angle bisector, okay, here's my suggestion. Angle bisector line returns an infinite line object. Okay. Then we have the notion in here of angle bisector segment, which is the finite line that ends on the other side of the triangle. Now, you've also got, is this well defined given that you have a particular vertex P? Don't you need to know the second vertex to define an exterior angle bisector?
No, because this has no way of specifying a half line. This always is either the line segment or an infinite line.
Well, right now, but you're proposing that it might have a half line. But I see, but you're saying without the half line, it doesn't matter which one you're talking about.
And I'd rather that not be a new string argument that will also have a...
All right, well, fine. But I suggest adding the angle bisector segment. That means the finite line ending on the other side of the triangle.
That's what we are calling angle bisecting Sebian right there. Second from the top.
That is a much more obscure name for the same concept.
So
I had literally never heard of a Sebian. So I want to just do a little poll here. Roger, had you heard of these things?
No, not Sebian.
Charles?
Well, at the time when the first time, when we did the design, but no.
I was talking about having heard of it. Okay.
I will say.
So what about the other people in here? I mean, like Michael and so on.
Heard, but didn't exactly know what it is.
It's one where, like, I wasn't exactly aware of it, but once I saw it, and once I was aware of it, I started seeing it everywhere.
You mean the word or the concept?
The word.
Wow. Okay.
Like if once I knew, oh, this is a thing I should pay attention to.
What is it? Where does the word come from? Is it named after a person?
Seva. So like, remember Seva's theorem is it's a theorem we use a lot as an example for the geometric scene project. But anyway, the guy Seva has did a lot of triangle work, so this is named after him.
I personally think angle bisecting segment would be more clear what it actually is than the Sevian thing.
Right.
So you do not want the list with infinite line or half line.
No, I do not. I think that's a total mess.
Right.
I mean,
I'll remove that.
Okay. And also, if you wanted that sort of list or something, I think you can get a Sevian endpoint. So that will give you you can construct whatever half line or whatever you want, as long as you have the 2 points, which you can get from
so you'd have to do half line of triangle.
But by the way, I have a question here. So Bob on our live stream is saying, good test would be to translate Euclid's elements into this. Well, guess what? We've been doing that, but I actually haven't seen that. Could somebody show that for a second? Because I'd like to see roughly what that looks like as an indication of how these functions are working.
Yeah.
Do we have some of that?
I can
control it, but
try.
I have to leave to an external meeting.
Right.
Yeah, and I also have to leave soon. But so Michael, unfortunately you should go. But let's take a look at this.
Ian has this under control.
Okay.
I'm gonna just pull up the tech conference slides. I'll share when I'm ready.
Okay.
Right. I mean, and maybe this is fine, but I would think in the angle bisector function, or if you call it angle bisector line, I mean, I think it's fine to keep it as an infinite line when you give it points. But I think if you give it a triangle, probably the segment is what you probably
and we've got 3 syntaxes here, which we have not documented. So one is the angle bisector line of a triangle. Another is angle bisector line of the P arrow Q, Q1, Q2.
Right.
And I might argue, maybe incorrectly, that in that case, maybe this is nonsense, one should give it, the result should be a half line. Is that completely crazy? Because you're distinguishing, I mean, I don't know, maybe it's crazy, but it feels like there's a directionality to that arrow.
I mean, it will match with planar angle because that's the way planar angle was specified. If you give those specification P, Q1, P, Q2, that means it's essentially the angle formed by the triangle at the point P.
Right. But if you add like exterior as the second argument, then like I guess you could canonically determine, which of these half lines to choose as the exterior angle bisector, but it's still going to seem rather arbitrary to a user.
Okay, I'm ready.
Okay, let's take a look. Go for it.
See my screen?
Yep.
Yeah.
This resized everything.
Yeah, that's Peter's side. There we go.
Okay, so these are now entities, is that correct? Are they in an entity store, or where are they?
They're in alpha.
Okay. But so they are accessible from the language, is that true?
They're dev mode exposed right now, but should be able to go live with 12.1.
What is the entity type?
Geometric scene.
Is that really the right name for it?
So some of these are theorems, some of them are just nice situations that have names, some of them are constructions.
Show me an example of so Euclid book 4 proposition 3, what does that mean?
So
it is nice that after a few thousand years we can actually make this stuff computable. Why isn't, given that it's Euclid book 4 proposition 3, eponymous people is surely Euclid?
Because it's in a pre-release state.
Okay, well anyway, where's the computable version of this?
Right. So this has a property called scene that returns a geometric scene object, and some of these also have alternate scenes that.
Okay, so like take the scene thing from that, and let's take a look at it. Why are those dots so far away from their letters?
I see. This might require the prototype.
Yeah, there's definitely require the prototype. Did all these scenes actually get good pictures all the time?
No.
Right. I don't know what. Usually, if there's a bunch of tangencies, it doesn't always work great. That one actually looks.
So I haven't.
It pinked.
Yeah, this is a bug I think is already fixed.
Right.
What does the step mean up there?
Oh, so it's a construction. So this will be for 12.2. If you, for the second argument, if you give, instead of just a vector of
this is the first
assertions,
step. Second step.
You can do a list of lists, and each sublist is a construction step.
Really? It doesn't geometric scene flatten sublists like graphics does?
Does in 12.0.
It used to, but if you want to...
Can I make a suggestion that you make this an association instead? Because then you can name the steps. And then you don't have an ambiguity. So
you would have to name the steps then, right?
Right.
Well, you can name them 1, 2, 3.
So currently for this branch, if you do there's a canonical way it will transform a non-vector into a list of vectors. So if you have a whole bunch of crazy, list structures here, it will find a way to canonically turn it into something it can handle.
I think a list of lists is the right thing.
Yeah.
I've got another design suggestion we've been talking about, that it should always be a list of lists. But if you're not familiar with the steps yet, then
okay, fine.
Yeah.
Well, but this concept of a stepwise, I mean, in a sense, this is like layers in a construction of some kind. I mean, in some sense. And is it the case that the successive things merely add to what is already there? Is that true, or can they take it away?
They only add.
I see. Okay, fine. All right.
And
well, I
also
slightly take back my comment, because I can imagine then two forms of visualization: one in which you flatten everything and just say, "I want the bottom line, the end," and
right.
one in which you say, "You
and we'll have ways to get both."
Right. And so for example, having a button that is like the give me the end rather than pressing the last.
Implemented.
Yeah, already.
Dan would have to show you.
Right. But yeah, so basically,
keep showing that. Keep showing.
Okay.
Yeah. Right. So basically, in the big old PR that Itai is currently reviewing, we have like in Manipulate, there's that little plus icon button in the top right.
Yes.
So we have one of those, and if you want to print out the whatever geometric scene you're looking at, including, since in the 12.2 it'll be you can dynamically move the points around. Whatever you move the points around to, whatever step you're looking at, you can just print that out as a geometric scene. So
okay, can you just show me a couple of other random things here? So by the way, again, I want to re-comment on those dots being, and you could go down to a slightly smaller magnification, and those dots are too far away from the letters for some reason. I don't know why. Okay, but go back to your list of random things that you had. So in this random entities for geometric scenes. So these scenes, so how many of these do we have? And how much Euclid have we done?
About 300. There's certain books in Euclid that are relevant to geometric scenes, and we have all of them except for a few that have to do with circle arcs that we don't have.
Sorry, I spaced for a second. What did you say? You have...
Okay, so only books 1, 2, 3, 4, 6, and 13 are relevant to
why? So other ones are random arithmetic things, and
other ones are purely number theory, or they're 3D geometry, or they're really specific about proportions and things like that. If this is to this as this is to this, and so on.
Fair enough. So, okay. So of those books that are planar geometry, what fraction of the propositions do we have?
All of them, except more or less like 5 or 6 propositions that require a notion of a circle arc that we don't have a good story for.
Well, we do. Wait, so what, do you have any of those off the top of your head, Ian? Because I do support partial circle arcs.
Yeah, so in order to do a circle arc, you have to specify the angle endpoints, right?
Right. It follows the circle.
That's not a good story for representing Euclid. You're not going to say this is the circle from angle θ1 to θ2.
You're going to say it's from point such and such to point
A to
point
point. So we need like a circle arc through or something.
Well, I mean, you could have symbolic. It would be clunky, but you could use symbolic radii and angles, and then just set points.
That's ugly.
Yeah, that's what I mean. It's not a good
circle through. Listen, as you say, you've got circle through, and you also need circle arc through in some way.
I don't see the point in trying to represent Euclid these propositions with some really clunky.
Right.
Well, no, not with explicit angles. I don't exactly know the construct, but circle through is generating the whole circle. And maybe there's some way to change circle through to represent the arc. Or alternatively, there's a separate circle arc through, which, by the way, seems like a useful construct in its own right.
Right. Actually, at the tech conference, I was talking to a guy from industry who was wanting to use random.
That's us. Anyway, go on. Sorry.
He wanted to use random instance and geometric scene as to do like CAD type drawings. And one thing that comes up again and again would be have this circle arc through.
Yep, absolutely.
But yeah, except for literally like 5 or 6 circle arc propositions, we've got all of the plane geometry from Euclid.
Well done.
And
it really works. And you can write all that stuff out. And is there a typesetting form for that? Go down again. Is there a nicer typesetting form for that geometric scene that you have there?
No, right now, an abstract scene formats like this and a concrete scene is that visual diagram.
Can we imagine a better typeset form for this?
I mean, maybe this could be a summary box. I think it'd be weird to sometimes be a summary box and sometimes be a graphical thing. This is more like graphics in that regard.
Yeah. And if it's a summary box, it's not really editable, right?
Yeah. Fair enough. I mean, this is the computable version of Euclid, so that's what it looks like. I mean, it's not unreadable.
Yeah.
By any means. It's cool, really cool.
Yeah.
And by the way, does Raj know on the list of upcoming things for 12.1? Does he have this on there? Because it's kind of a major thing in my view, and I don't think I've ever seen it on that list.
Well, so we originally were going to do a bunch of these geometric scene updates for 12.1, but I think there's enough design review it turns out we're going to have to go through that. I think we're pushing back to 12.2. So
that's unfortunate.
Right.
I think that should be looked at more because I think it'd be really nice to get this out.
But I think this entity stuff will be ready for 12.1.
Right, but Ian,
but you'll need to flatten all of the scenes.
Right, we'd have to flatten the sign. They wouldn't be constructions anymore.
So it goes.
There's a question of if we need to flatten it.
I wouldn't flatten it. I would leave it unflattened.
Leave it like that because
then it can come to life in the next version as something which has separate steps.
Yeah, and in version 12 handles this.
Oh,
it just flattens.
It just shows you the end result. It doesn't.
It treats it as if it doesn't have steps, which might mean some of them won't.
What you could do is have a property in here that's called construction steps, and have that be a list of geometric scenes, which is not as elegant, but it will at least give you something.
I think actually we can't do that.
Why?
We need a geometric scene aware kernel on the alpha side.
No, what? But
to do that computation to tear it apart.
But I'm not suggesting. You mean to do it dynamically? Well, you can do it as a computer anyway. I don't need to solve the engineering. Said that's what I suggest because I think you can do that on the client side. If you have to.
I can look into it if possible.
There. All right.
If I can just sort of summarize or make one summary point, I think given that you've wanted to change possibly every single function we looked at, or certainly close to that, that we should leave these as experimental for 12.1.
Yeah, I was. I wrote these suggestions up several months ago. Like even the ones.
Well, that's a disappointing conclusion, but I don't completely disagree. I mean, I'm just horrified that angle bisector is something we've had to spend a substantial part of an hour discussing. But I mean, okay, so anyway, my summary suggestion is the one that I just made about the different input forms giving different things by default, with probably the possibility of having some additional string argument, just like we do in the case of triangle construct, that would give you a different one if you fed in a particular input form.
Yep.
Makes sense?
Yep, we'll look into that.
Okay, a couple of comments on our live stream, including the statement, "This appears to be a can of worms," which I agree with. Somebody talking about polishing existing functions, which we are completely aware of and are very much doing, but that's just not the subject of this particular meeting. Let me see. Could be argued to have a pair of perpendicular lines crossing at a single element. Oh boy, no. Bob is saying, looks like you might need some kind of zoom on the scene.
Oh yeah, that's already implemented in the current PR.
What does it do?
So the new geometric scene will always format as a dynamic module where you can move the points around, and there are buttons where you can. There's like a plus button if you want to zoom in, a minus button if you want to zoom out, and then there's left, right, up, down buttons if you want to move around.
Okay, so hold on. Is that consistent with the way dynamic geographics works? Because it has a UX for that.
So dynamic geographics, if you want to, it has a plus and minus button. If you want to move around, you click. You just click on. But we can't do that for geometric scene because we want to be able to move individual points around to actually change the scene. So that works.
Is that obvious that you can't have a click target that is, if you click on the background, you get to kind of thumb it around, move it around?
So it works like a it's a locator pane. So locator pane, if you don't actually click on a point, it goes to the nearest point. So that's how this works. I mean, it actually is a locator. It's definitely consistent with locator pane because it is a locator pane.
And locator pane doesn't allow you to have the background.
Right.
You click anywhere and it finds the nearest one.
Right.
Is it possible to make it to where?
Why don't you ask John whether that's
work if you click directly on the disk?
Why don't you ask John whether that's really what has to happen for locator pane?
Or
Okay.
if there's an alternative to locator.
Right.
Yeah, because I think if we are going to have sort of movability, it's kind of clunky to have another metaphor for that.
Right. Well, so the other option is if you can do like a shift click or something that won't move the
Nobody
points.
will ever be able to discover.
Exactly. Yeah. So currently there's buttons you click on to move it left, right, up, down. Just to get around that.
Okay. Ethan is mentioning Landau's analysis book. Actually, Michael has talked about that book and using find equational proof on it. Maybe somebody here knows about that. That was a thing that has been talked about.
Yeah.
There's a question about 3D.
Jose.
Say again?
I was just saying that's a Jonathan Jose thing. We're not in the loop on that.
Fine. What about 3D synthetic geometry?
It's so for at least for random instance, getting it to work in 2D is kind of the edge of our computational abilities, just for it to run in a reasonable time frame. So 3D we're trying to keep the design open if we eventually want to go there, but we're using IP-opt for basically all the random instance computations, and kind of getting things to work reasonably in 2D is kind of pushing it already.
Wait a minute. The problem is this is effectively integer programming, you're treating it like a constrained optimization
Yes,
problem?
it's a constrained optimization problem. So
Okay.
yes.
But I thought, I mean, now with all of our fancy constrained optimization, so like Roger, does Roger agree that this is undoable in 3D?
I have no idea.
Right. I would.
I mean, I think.
It depends on how they map it and what kinds of problems.
Yeah, I mean,
Right.
There are more than one way to map this to constrained optimization. So.
I have a feeling that it is worth having one meeting between you synthetic geometry people and the constrained optimization team.
Right. I will say so certainly things that just kind of involve lines going through points we could do, but there are more, and although I guess in 3D we don't really have a great notion of 3D circles already. So that would be something where, I mean,
I think it's worth the discussion, because even if simple cases can be done, it's potentially very valuable. And
okay.
I have no idea what it looks like, sphere through whatever, dodecahedron through whatever. It obviously can get very complicated, and not all of it is relevant.
Right. Yeah. Tangent assertions about tangency are
horribly complicated, because you
Yes.
have lots of different tangent planes and God knows what else, and it's a
Right.
big mess.
Well, even angles, right? I mean,
Right.
planar angle only works in 2 dimensions because that's the only.
I understand, because otherwise it's other kinds of angles.
Geometric scene 3D would have to support dihedral angle and
right.
solid.
I think you guys should look into it. I think there may be a slice of it that is easy to define and fairly easy to implement.
Okay.
That will be worth having, even if you can't do the absolutely general case, which I don't even understand what it would be. And if you imagine what Euclid was doing, I mean, I don't even know what the state of the art of Euclid style proofs in 3D is. I mean, I guess the things I've ever seen, I suspect there are simple cases that would be very useful to people that, for CAD-like constrained things that don't get into all the issues of, dodecahedron through whatever.
Right.
Would
you, off the top of your head, do you think it would be a geometric scene 3D head, or just geometric scene would work for 2D and 3D?
I would guess it will be a 3D head, but I'm not sure.
Well, we would definitely need to do that now I think about it, because there's because if you just have, geometric scene of list of points A, B, C, D, and then you have, line through of A, B, C, D.
Yeah, you don't know.
There's no way to know.
Right.
Okay, well, then that would also be better, because we could just say, for geometric scene 3D,
these things don't work.
Right. Okay. Yeah. This actually, this is if we do it that way, then this is much more doable, and I can just restrict the stuff that's just not going. Most of the stuff that would be computationally difficult is stuff like circle, where we don't really have a great way of representing it arbitrarily in 3D anyway. So it's clear it won't be supported, at least for now.
Spheres.
Right, spheres. Yeah, we will.
The sphere is the perfect shape. If we support spheres, what else do we need?
We literally only support spheres.
Okay, one question here that I think is interesting is about documentation of Euclid's elements and what we're planning there. We should have a conversation about how we expose this stuff.
So we have the answer, right? So we're going to have a documentation for the entity type and go into the Euclid's elements is just one.
Yeah, but that's
class.
Pretty lame. I mean, it would be, honestly, having the computable version of Euclid would be much more, having an actual website that is the computable version of Euclid would be much more impactful.
Thinking something akin to the function site, Wolfram function site, or that exists, right?
Yeah, but I mean, why not just have something where we have, Euclid, a page, just a version of Euclid that simply has the computable version on each page. Book 4, proposition 13, the statement in English as you have it in that thing, and just expose it as a computable version of Euclid. Seems to me rather useful, and it seems to me like a nice thing to do that highlights what we've achieved with doing this.
Yeah, that sounds
Okay.
very similar to Wolfram Functions site. So I think we should.
Well, yes.
Yeah.
So, separate discussion about that. You can have me part of it. We can brainstorm about that for a little bit. And Ethan is saying put Euclid in the notebook repository. Yeah. Well, I think we can do even better than that. Okay, 2 more comments here, and then we've got to wrap up. And we unfortunately got through pathetically little in this de-experimentalization meeting. Euclidean geometry in Minkowski space. I don't think we're not doing that yet.
No.
It's not Euclidean geometry. It's Minkowskian geometry.
Yeah.
Oh, that's right. Somebody's asking how my physics project is going. Actually, it's going great. There will be more to say about it in a few weeks. But that is absolutely irrelevant to this discussion, except for the fact that Charles is getting all kinds of bug reports and questions about graph functionality. Okay, well, this was a little disappointing in the fact that we really didn't get. Oh, look at that. We got 1 out of 7 of these things covered today. But
Raj, if you're still here, can you move numeric array and library link next to compiler, because those are related things?
Okay, all right. I got to run off here. Thanks everybody. There's very nice stuff. I really impressive functionality. Pity angle bisectors are such a complicated concept.
Yeah.
All right, and thanks to folks on the live stream. Lots of great comments. Much appreciated.
All right.
See you all soon.
Bye.